Hey guys, it's George. I'm the builder and driver on Greenhouse, and today I'll just be doing a brief overview of our States robot. Um, just generally, it's pretty simple. It's an S-bot with the redirect, wing, match rotor, yada yada. Yeah. So jumping straight into it, we have this drivetrain. It's a pretty standard 450 RPM drive on 3.25-inch wheels. And you'll see a lot of other teams do this, but the two wheels that are closer together are in the back. And this allows us to go over the parking zone really well, because since the middle wheel is in the back, right? Whenever you ramp over, and when the back wheels gain traction onto the, the on pod might be done. Okay. Yeah, when the back wheel gains traction onto the parking zone, it lifts the robot up like it's like a lever. It pivots it up from the back, and that allows us to clear the parking zone really well. I can just demonstrate right now. I'd have to push it though, so. It's not just the drivetrain, of course, but the drivetrain plays a crucial role in clearing parking zone and being able to ride over it really easily. Yeah, so you can see it literally tilts the entire row up back like this, and that allows you to just essentially clear the parking zone really well. Another thing that we have is this massive motor stack in the back where all three motors are clustered really close together. This allows us to open up this entire front area for intaking, which is why it intook three blocks really well. And it's just good for skills. It's also just good overall. It also means our match loading can be pretty fast because you don't have to final to one block. Although it's not really that big of an issue. All right, next we have, speaking of which, the match loader. I'd say it's pretty good, but it's pretty standard. It's on two pieces of L channel that are mounted really close to the front of the robot. It's powered by, I think, a medium piston. No, it's a long piston, never mind. Yeah, so it's powered by a long piston, consists of a piece of plastic and a really, really loose rubber band. The looseness of the rubber band actually makes it really good because it requires less force to enter the match rotor and be able and pivot up, which is really good for match play. If you don't, it's good for everything because you don't have to spend extra time to drive into the match rotor, and it just makes driving and programming more consistent. So I just demonstrated it. Okay, doing it by hand is kind of a pain in the butt, but yeah, as you can see, it's relatively fast. It was faster before, but I removed some stuff, and now it's a little bit worse. So yeah, moving on, we have this floating stage right here. It's not very well braced, but it works in the end. It used to have double chain, but one that fell off at comp, couldn't find it. But anyways, going back into the more important stuff, the spacing of this flex wheel is pretty well tuned. So as you can see, unlike other robots that have a really wide gap between these two flex wheels, I chose to have a really close gap. This allows us to clear the parking zone really well. This is the other reason why we can clear from the front really well, other than the drivetrain layout. And despite popular belief, if you tune your intake well enough, it doesn't matter where you put your flex wheels when you match load. It'll match load the same speed every time. And so moving on from that, we have this wheel right here. It's connected to the flex wheel stage, and everything runs at 1,200 RPM, by the way. It's powered by 11 watt, and it's right here. And basically, it just brings the blocks up even further. Pretty standard. And then next we have this roller right here, which runs at 600 RPM, I think. Running on a 5.5 watt here. And it actually has a lot more torque than we expected, but it can keep the blocks in there relatively well. And then last we have this hood right here, or redirect. I'll go into more depth later, but it's 1000 RPM on a 5.5 watt. A lot of people say that it's pretty fast for a 5.5 watt, which I agree. It doesn't have that much torque, but it's enough for our purposes. And then finally we have this wing, which is pretty standard. All right, so go into more detail on the S part. As you can see, this robot, the S on this robot is very shallow. Like you'll see other robots that travel through here, and that allows you to store like 10 or so blocks. Ours can only store like 8 or 9 blocks, but with this like shallowness, we can make the intake really fast. So this is the reason why we have really fast RPMs on 5.5 watts. And the reason why we didn't choose to like combine 22 watt intake like 10 ton G or I think 197 something, 197A or something. It's because if this bottom stage gets jammed, the top stage will immediately stop as well. So in order to like mitigate that, as well as the hood, and so in order to mitigate that, we split up into 3 sections, and this allows us to avoid jams at all costs, which means that it can still score the top section without having to like mess with the bottom section. And of course we still have an anti-jam, but it's just like easier to use. We only have to spin one part, and usually it's only this part that gets jammed. So yeah, well, I mean, I don't know, it's not spinning. Anyways, a bit of technical difficulties here, but yeah. So next we have going into more detail is this redirect. As you can see, it's really similar to Snacky Cake's new design, but instead of having the pivot point all the way back here, we decided to move it somewhere like near the actual pivot, near the actual like scoring mechanism itself. First reason is because I'm too lazy to make a really long beam that goes from there to there. Like the space we have here is like really small. I don't want to make extra space for it. It's too much work. And 2, it doesn't really make that much of a difference. And 3, we already had this design previously. If I can find it. Never mind. But it's like the old UCF redirect, but instead of a piston being here, the piston's back here, and instead of pivoting up like this, it pivots up like this. Yeah, I don't know. But it's just better than UCF because you only have one exit the blocks can go out of, and that just increases efficiency and like consistency. But all right, now hopefully I fixed the intake. They can probably score now, but yeah. And then the middle goal is just the same thing, except it drops down and it's at a lower velocity. And so as you can see, like the high RPM lets it score really well. That's like the only benefit. And people also wonder like, how do we have enough torque for it on a 5.5 watt? It's literally just just tuning intake friction. As you can see, the intake friction is like pretty low. And the secret to this is, this might be a really jank method, but these like pillow bearings are able to wiggle around. So like despite like, if anyone rams you, these like absorb the impact and maintain their original position. It's the same for every single one of these bearings here. They can all move around. And this one, we also use what's called like the standoff retainers. These things right here. It's like, it has a hexagon inside it. I don't know what it's called. Hand standoff or like hex nut retainers. Since they have less points of contact on the shaft, they tend to have less friction, and that allows us to have like 1000 RPM, which is pretty cool. And then our hood right here is connected to the redirect, because why not? It just works. So I'm not gonna change it. And this wing right here, we stole this tech from our sister team 13722V Invictus, but this wing has a lot of bracing inside it. Well, it's not really a lot of bracing, but it's enough bracing to get us to not bend. So throughout like I think one local and states, this thing has not bent at all, surprisingly. And the reason behind this is because these shaft collars, the high tension shaft collars, fit perfectly inside a C channel, and by linking them with the standoff like this, you can like mitigate all bending. It just even if it bends, it just snaps back into place, which is really handy. And yeah, thank you to our sister team for giving us that idea. And then next we have just this pretty standard lock mech and this aligner, which is just a bent standoff. Me personally, I don't know about you guys, but the plastic aligner is kind of bad for my driving. I've heard it works pretty well, but I'm just too lazy to tune it for my purposes. So this just allows you to pivot. This allows you to pivot on the goal pretty well. Like if your wing is in there and you want to like move around, you have like a full 180 degree motion that you can take, or that you can use. It's just good for like spin D-score, where you just like spin in place and D-score the full goal. I did try to attempt this during semifinals at states, but ended pretty poorly and we lost. So yeah. And then last thing I'm going to go into more detail is this intake lift. We originally had a double park like in between here, but I scavenged it for long pistons. And the problem that we have right now is that we don't have enough solenoids. So in order to actually use double park, you have to switch this tube to up here, and that will allow us to like use double park. But this intake lift is really important, so we never really use double park at states. Instead, we just allocated it to the intake lift. And even though it looks really jank, like if you look from the front, it lifts it unevenly. That's totally fine, because when you're scoring low goal, it doesn't really matter. In fact, it actually biases it to one side, which is pretty cool. And during skills, our low goal was actually more consistent than our top middle goal, which is really surprising because we've never had that issue before. Oh, it's not really an issue, but we've never had that situation before, and this is like the only time that it happened, and it's all thanks to this intake lift. I took inspiration from some lever bots that I saw in Robolytics. Thank you to I think Corsair R, some other teams that recommended an intake lift. So yeah, I can just like quickly demonstrate it. So yeah, for our S spot doesn't really need aligners at the bottom. You just line it up like this, and then just outtake. And you can slow it down and whatnot, but if you have at max speed, it de-scores the other team's blocks while also being able to score yours. And that's pretty neat. And then, like programming wise, it's pretty simple. We have 3 distance sensors, 1, 2, and 3 for distance reset. We have this color sensor up here for like color. Like during autons, you don't want to score the other team's color, so we just stop it at this position. And then one down here for double park, though we could use it for like match luring. Like if you don't want to intake the other blocks like at all, then we can use that to stop the intake. And some other specifications is that we run 2 air tanks. We have an ODOM lift, and we only run 1 ODOM pod because it's actually pretty consistent, like only using a vertical pod, even on full drift drive. So we'll probably use that on our next spot, except we can't really predict the horizontal movement, so I don't know how that would go. And I think that's it. I mean, we also have this aligner, which is like really wiggly, but it works, so I'm not complaining. It did snap, as you can see here, which is the reason why it's so wiggly right now. But yeah, and then I recommend also putting all of your shit at the bottom. That's just to like make your center of mass as close to the ground as possible, especially if you're running like if you're putting your wheels on the bottom hole of your Z channel. This is especially important because when you do this, your robot tends to tip a lot. Like even right now, it tips a lot, but same thanks to our like pretty low center of mass, it doesn't tip as much. Like it's never tipped over completely during a match, which is really good. And by doing this, you also mitigate the chances of getting stuck on the goal with your wing, which is obviously a DQ. So yeah, it's anti-DQ, which is very good. I think that's it. Might have been confusing. If you want to ask any questions, just comment down below, because I know I just did this explanation like for like a pretty short time frame because I need to get back to building my own robot. But yeah, see you guys in the next video.